Hello and welcome back. Today we're going to be talking about dimensional analysis, which is a problem-solving methodology that we'll be using in chemistry quite often, especially once we get into units 5 and then all next semester. But dimension analysis, dimension is a different way of referring to a unit. Okay, but dimensional analysis is a systematic approach to problem solving that uses conversion factors. To convert from one unit to another. Okay, a conversion factor is just a ratio of two values having different units. And a conversion factor can be written in two different ways. We all know a bunch of conversion factors already, right? If you can convert from seconds to minutes in your head, or minutes to seconds, or even inches to feet, or feet to inches, you are doing dimensional analysis. You may not recognize it as what it is, but that's what you're doing. Because, for example, this conversion factor, 1 hour is the same as 60 minutes. It's a conversion factor. And two ratios, which are both equal to 1, can be written with this information, right? You can say that 1 hour over 60 minutes is equal to a value of 1, and which is equal to 60 minutes over 1 hour. And which one of these you use if you're trying to convert something, depends on if you're trying to convert minutes to hours or hours to minutes. Because, for example, if I was to ask you how many minutes are in half an hour, in your head you're either using this conversion factor or this conversion factor to do that. Likewise, if I said how many hours was 120 minutes, you're going to use one of these as well, but you're not going to use the same one in both those cases, because in one case you're trying to go from minutes to hours, the other one's from hours to minutes. And hopefully it'll make a little bit more sense when we work a couple of example problems. So, key to be successful in solving dimensional analysis problems is you're looking to identify what you're given, what unit you're given, and what you want to end up with. And then you need to use one or more conversion factors to get from what you're given to what you want. Because remember, if you needed to convert from minutes to hours, the conversion factor directly from 60 minutes is the same as 1 hour. However, if you are converting from seconds to hours, you're going to have to use two conversion factors. One to convert from seconds to minutes, and the next one for going minutes to hours. So keep that in mind, that oftentimes you'll need to use more than one conversion factor to get to what you want to get to. And what dimensional analysis is, when we get down to it, is just kind of lining up all our conversion factors in a mathematical expression so that our units, the dimensions, cancel out. And hopefully you know that, it'll make more sense when we get to this, but it's just, if we multiply the values above the line, we multiply those together, and we divide by every number that's below the line. And at the end, you just have to make sure your answer has the correct number, significant figures, and units. Okay. So in this first one, we want to convert 79 centimeters to meters. This is what we're starting with, and this is where we're wanting to end it with. So we're trying to convert from centimeters to meters, and yes, you do know the conversion from centimeters to meters, or at least you should, because remember, there are 3 metric prefixes that you are required to know, right? Kilo, centi, and milli. Your centi. So this is the value we start with. And now we need to put our conversion factor here. That's going to get us from centimeters to meters. Now, hopefully, remember that centi is the 100. And so there's 100 centi in any base unit. So there's 100 centimeters is the same as 1 meter. So now we just have to figure out, okay, where do we put the 100 centimeters? On the top or the bottom? And where do we put the 1 meter? On the top or bottom? And the beauty of dimension analysis is that your units will help you line up your work. Because if your centimeters is here, and you can also think about this as just being over 1. Centimeters is here. If we want the centimeters to get canceled out, would we put the centimeters up here or down here? And hopefully you can understand that the centimeters, in order to cancel out, has to go on the opposite side of what you're trying to cancel. Because remember, x times x gives you x squared. But x divided by x, to cancel out, give you 1. And units can be treated just like algebraic quantities. Right? One thing that you want to get in a good habit of doing is, I know this is a very, very simple problem for dimension analysis, but it's just a way to get started. And the one thing you want to do is see what units cancel, what's left over. So centimeters up here cancels with this, and that's it. You're left with meters, which is what you wanted. So you set this up correctly. If you had put the 100 centimeters up here, which is a very common mistake, and the 1 meter down here, when you go back in your work and go to see what cancels, well, with a 1 meter down here and the 100 centimeters up here, the centimeters are going to multiply together and give you centimeters squared over meters, which makes no sense whatsoever. This has 2 significant figures. This is a conversion factor. Conversion factors have infinite number of significant figures. They are like a counted quantity. They are assumed to be complete. So the only thing that you are basing significant figures off of is what was actually measured, which was this piece of data in the problem statement. Any conversion factor does not factor in to the significant figures because it is defined to be exact. This next one. We want it from grams to milligrams. Again, another simple metric prefix conversion, and one that you would be expected to know, right? Because you need to know how to change from kilo into any other of the metric prefixes, the basis unit of the centimilli, likewise centimilli. So that little m, that's saying for milligram. So 0.03991 grams. And the conversion factor we're using here, right, there are 1,000 milligrams is the same as 1 gram. So once again, we need to figure out where each one of these things goes. And in order to do this, without giving much thought to it, is just look at your unit here. Here's grams. So if this is going to get canceled out, I can't put the grams on the top. The 1 gram has to go down here. The milligrams goes up top. I can check my units. Those things cancel. The milligrams is the only thing that's left, which is what I want. So I'm multiplying this by 1,000. So it goes over 1, 2, 3. So it could be 3.991 milligrams. 4 significant figures here. My answer is 4. This is the defined constant conversion factor. Okay, this next one is going to take a little bit more conversions because you may not know off the top of your head the conversion factor directly from seconds to hours, and you're not expected to. But we're trying to figure out what are we starting with. Well, remember, even though it says seconds first in the problem statement, we're not starting with that. the data we're given is 40 hours. And hopefully you recognize there's a decimal place here, right? That is not just a typo and saying that's not the end of the sentence. That dot there is telling us that for significant figure purposes, this 40 has two significant figures. This 0 is significant. So we start with our 40 hours. We're going to use two conversion factors on this because I can't, most people can't go directly from hours to seconds, but we do know, or hopefully you know, 1 hour is the same as 60 minutes. And 1 minute is 60 seconds. And right, when you go back, you should be able to cross off all the units. So hours is here, we'll cancel with what's down here. This minutes, cancel with this minutes, leaving only seconds. If you go back and check your work and you had this one flipped or this one flipped, you notice you're not going to end up with just seconds. If this one was up here and the seconds down here, well, the hours would cancel, but then you'd have minutes times minutes, or minutes squared over seconds, which makes no sense. So this is a way that when you go back and check your work, and remember, you are required to show work on all problems. If you just put down the answer with no work, you will get no credit on any test or quiz. So please understand that. So my calculator is still in sight notation mode, so I'm going to take it out. So that's how many seconds are in 40 hours. And I just have to round it to two significant figures. So I would just report that as 140,000 seconds. Right, if you just, on a test or quiz, just do all the work in your calculator and write this down, you will get no points. Because this is, and this goes on with any type of calculation in this course. No work, no points, no credit, because don't know if you knew how to get this answer, or you just copied it from somewhere or something. So get in a good habit of showing your work with your units. This next one, how many inches are in 4.5 miles? And here you may not know how many feet are a mile. I also included this one there. Hopefully you know that. If there's any, besides these three metric prefixes, those conversions, if there's ever a conversion factor that you don't happen to remember, like for example, if you have a, just for some reason can't remember how many seconds are in a minute, during a test or quiz, feel free to ask me. I'll tell you that, with the conversion factor, if you need to, 60 seconds is the same as a minute. So inches are in 4.5 miles. So remember, this is what I'm starting with, and I want to get to inches. So I start with the 4.050 miles. I want to get to inches. So here's one of the conversion factors I'm going to use. 1 mile is the same as 5,280 feet. Well, what goes on the bottom? Right, whatever unit is here goes down here. Right, that's the beauty of dimensional analysis. That once you get the hang of it, your work will tell you what to put where. And if feet is up here now, I need to put the 1 foot down here and the 12 inches right there. And if I go back and check, this unit cancels with this, that unit cancels with that, I'm left with just the inches. So putting your calculator, 4.50, that's 3 single figures times the 5280 times 12. So to 3 significant figures, it's going to be 285,000 inches. Or you could also put in scientific notation 2.85 times 10 to the 5th inches. Either would be fine, right? unless it says to put it in scientific notation or not to put in scientific notation, you're free to use either one. Okay, this next one is the only thing tricky about this next one is that it wants to convert a compound unit, miles per hour, to kilometers per second. Whenever you see this word in a unit, miles per hour, which is right what all speedometers and speed limits are posted in this country, what that means is the unit is miles over hour, miles per hour. So when you see miles per hour, you should be thinking miles over hours. So we're starting with 35 miles over hours. And we want to convert the miles to kilometers and the hours to seconds. And all you need to do is convert them individually. Okay? And it doesn't matter which one you convert first. So, for example, if we want to convert the hours first, we want to get hours to seconds. And we're going to have to, we're going to use these things. We're going to go from first hours to minutes, and then minutes to seconds. Now, the only thing you have to remember is hours is down here. So if we want hours to cancel out, we need to have the 1 hour goes now on the top, and 60 minutes down here. Likewise, to get rid of the minutes, we know that 1 minute is 60 seconds. And now, if we were to stop this problem right now and multiply the 35 across times 1 times 1 and then divide by 60 and divide by 60, we would be left with miles per second. But we don't want miles per second, we want kilometers per second. So we just have to use this right here. Here's our miles. For the mile to go away, we need to put the 1 mile down below and the 1.609 kilometers up here. And now we're done. This miles now cancels out that miles. We're left with kilometers over seconds, which is what we're looking for. So now, again, you just multiply across everything on the top, divide by everything on the bottom. So it'd be 0.02 single figures. So we've got to round it to the 5 spot right here. So we look at the number behind, it's a 6. So it's going to be 0.016 kilometers per second. And our last example here. The density of air is given as 1.29 kilograms per cubic meter. We want to convert this from kilograms per cubic meter to grams per cubic centimeter. And when we're dealing with things that are squared or cubed, we have to be a little bit more careful. Because as I put a little hint here, 100 cubic centimeters is not the same as 1 cubic meter. 100 centimeters is the same as 1 meter. But 100 cubic centimeters is not the same as 1 cubic meter. So we've got our kilograms per cubic meter. Doesn't matter which one I convert first. Let's do the easy one first, the kilograms. I'm going kilograms to grams. So, 1 kilogram is the same as 1,000 grams. That's one of those metric prefix conversion you need to know. And that, if we were to stop right there, our units are grams per cubic meter. Well, we're halfway there. We want grams per cubic centimeter. Meters down here. We know that 1 meter is the same as 100 centimeters. But we have meters cubed here. If we just left it as 1 meter over 100 centimeters, one of these meters up here would cancel out with this down, one of these down here, and we'd be left with meters squared times centimeters. So what we need to do, is cube this conversion factor so that we get cubic meters on top and then cubic centimeters on the bottom. That also means that the 100 down here gets cubed. Another way to be thinking about this as well, remember, is if you don't want to, if this confuses you with the cubed, you can put another 1 over 100 centimeters and a third 1 meter over 100 centimeters. Mathematically, that's the same thing. So take the 1.29 times 1,000, and now we're going to divide it by 100 cubed. Or 0.00129 grams per cubic centimeter. All right. And you'll get a little bit more practice on the worksheet that goes along with this.